So today we're going to start on chapter 1. And so chapter 1 is titled Atoms. So now we're going to start talking about what the atom looks like, what the structure looks like, the periodic table, all that kind of stuff. Okay? So now we're going to start kind of getting to the foundations of chemistry. We'll also do a little bit of a history in this chapter. Alright, so to get to the very bare bones, let's start with the basics. So let's talk about matter. So what is matter? So matter is anything that has mass and occupies space. So I have mass, I take up space, so I have matter. Not that I matter, but that I have matter, that I'm contained of matter. Okay? The board here, it has mass and it occupies space, your cell phone. Another thing that people think about sometimes is, say, water. So water has mass, okay? And because if it hits you, like think about when you go out in the rain and if a water drop hits you, sometimes it can hurt, you know, if it goes really high and it's like a heavy rain. So it has mass and it takes up space. The oceans take up space. One thing that some people don't think about is like air. People don't always think about air as being matter, okay? But think about if you had a balloon that was empty, like without it being filled up, and then you fill up a balloon. It's gonna actually weigh differently. You could put it on a scale and see that it's gonna weigh differently. And it takes up space because that's why it stretches out your balloon and inflates your balloon. So matter is anything that has mass and occupies space. So what we're gonna do is we're gonna classify our matter based on 3 different things: solid, liquid, gas. And I know you've probably heard of these in your physical science classes, but we're gonna define them from a chemistry perspective. So this table here is going to be a summary. We're going to break down each one, solid, liquid, gas, in the next couple of slides. But this is a summary of everything I'm going to talk about. So fixed means it keeps its shape when it's placed in a container. And indefinite means it takes the shape of the container. And then we're going to talk about the shape, the volume, is it compressible, and does it flow? Alright, so let's talk about first about solids. So what are solids? So you think of examples of solids, but I want the chemistry definition of a solid. So solids are particles that are packed close together and fixed in position. So particles that are packed close together and fixed in position. This is my solid. So here's kind of a picture. Here's some solid, and this is what the atoms look like. So a solid, you've got your 2 atoms. They're close together, and they're fixed. Now we'll talk about later, they're actually vibrating, but they're not moving around. So they're here, and they're vibrating. So fixed position, they're not moving about, and they're close together. So let's talk about a few things. So let's talk about their shape. Is it going to change based on the container or not? So think about if I have a solid like a book. If I put a book in a box, does the book change shape to match the box? No, it has a fixed shape. It's going to be the shape of a book. So the shape is fixed. Let's talk about the volume. Okay? So remember when we talked about volume, it's the space that it takes up. Okay? So a book is going to take up the same amount of space regardless. It's not going to expand to the room or anything like that. If I put it in a box, it doesn't expand to the box. Okay? So the volume is also going to be fixed. Alright, let's talk about, can it be compressed? So is it compressible? Okay? So when we talk about compressible, let's think about the definition. They're closely packed. So if they're closely packed, can they get closer? Well, you might think in my example right here, well, your hands could get closer together. Okay? But we're talking about if it's in the definition being that they're packed close, then that means that I can't pack them any closer together. Okay? So if they're already close, that means I can't compress it more. So they're not going to be compressible. So this would be a no. And so we call these incompressible. Okay? So they're incompressible because they're already packed tightly together. And the last one is flow. So can they move about? kind of think about like water, is it gonna flow? So since they're packed close together and they're in a fixed position, they're not moving, they're vibrating, but they're not moving, they're not gonna go anywhere, so then they can't flow. So no flow. So they're fixed shaped, fixed volume, cannot flow, and not compressible. Now, there are two different types of solids. The first type are called crystalline solids. So these are solids that have a nice ordered geometric pattern, okay? So they're not just randomly. So if you notice, this kind of looks like a nice little geometric pattern. It's got the same pattern as it goes up, from left to right, top to bottom. So it has a nice orderly pattern. I'm gonna go to the next one just so you can compare them and I'll come back. So this is crystalline, it has the nice orderly pattern. Whereas amorphous, they have a random distribution. There's no pattern. So if you notice, the particles here, they're just kind of wherever. There's no nice pattern, rhyme or reason. So the structure of these actually affect the properties. So these guys are random, they're not in a pattern. That's amorphous, whereas the crystalline are in a nice pattern. So because they're in a nice pattern, it's going to affect the properties of my solid. This pattern actually makes it really, really strong. So an example would be salt, but a really good example is diamond. So diamond is made out of carbon. That's one of our elements we'll talk about. So solid carbon, if it's a crystalline form, then it's a diamond. And we know that diamonds are really, really strong. And they're strong because they have this geometric pattern. Now, carbon, as a solid, can also be in its amorphous state. And when it's in its amorphous state, we call it charcoal. So same element, it's still the same state, it's a solid, but the substate, the type of solid, is amorphous versus crystalline. So that little bit of a difference changes it a lot. Diamonds are the hardest. Charcoal, we know you hold it in your hand, it starts getting all crumbly. You got like all the charcoal going everywhere and it's all crumbly and stuff, okay? So big difference between if it's patterned or not patterned. Some other examples are plastic. Now you might think plastics are pretty strong, but remember, like, you can hold a plastic bottle and crush it, okay? Glass and then charcoal. So just some examples of some crystalline and amorphous solids. All right, our next one that we're going to talk about are liquids. So liquids, these are particles closely packed, but can move around some. So these are particles that are closely packed, but they can move around some. Okay? So look at our picture, it's a little bit different. So this is some colored liquid here. So they're not just here, they're still close, but instead of them just being here and vibrating, now they can start moving past each other. Okay? Still close together, not super spread out. Close, but they can move past each other now. Okay? So closely packed, but can move around some. So let's talk about a few parts. Shape. So since they can move, if I were to put a liquid into a container, it can move in the container and it can change shape. So just think about, you know, if I had water or whatever, if I spilled the water, it's not going to just keep its shape. Like ice cubes keep their shape. When it's a liquid, it's going to spread out to whatever the container is. So if I dump it into a bucket, it's going to spread out. So their shape is going to be an indefinite shape. All right, volume. Okay, now with volume, this is where some people get this one a little confused because you think, okay, well if I take it and it spreads out, it's taking up more space. Okay, but it's actually not. The shape is a little different, but it's not necessarily taking up more space. So what we want to think about with volume is we want to think about like how much do you have. So if I had a whole Coke bottle of Coke and then I poured it in a bucket, I still have the same amount of Coke. So the amount that I have hasn't changed. So when we think about liquids, it's not that the atoms here, they're still closely packed together. They're not creating space per se. They're not spreading out and creating space. So my volume is always going to be the same amount. So the volume is going to be fixed. If you had a 2 liter of Coke and you poured it out on the floor, you still have a 2 liter of Coke. Now it's just spread out on the floor. Okay? Compress. Let's see if it can compress. So we said that this is the liquid and it can move past each other. But in our definition, we said it's still closely packed. So if it's still closely packed, that means I can't make it any more packed. So that means it's not compressible because it's already really close together. So because of this closely packed part of our definition, I cannot compress it anymore. So compress is a no. It's incompressible. All right, last one is flow. All right, so they're still closely packed, but now since they can move past each other, they can move a little bit, that means they're able to flow. Okay, so this is why we talk about like rivers and all that, the streams, they can flow. All right, so those are liquids. They're closely packed, but they can move around some. On the next lecture video, we're going to talk about gases.